Hey there, it's Shannon Math Chick Myers, and today we are looking at a mixture example from 3.1 of the ZIL text. So here's the situation. We've got a large tank filled to capacity with 400 gallons of pure water. Brine containing 3 pounds of salt per gallon is pumped into the tank at a rate of 4 gallons per minute. The well mix solution, that's my version. You can see why I'm not an artist here, but this is the mixer here. My attempt to draw. So it's mixed really well, and it's pumped out faster. It's pumped out at a rate of 8 gallons per minute. So we want to find the number amount at time t of pounds of salt in the tank at time t. So let's check it out. We know that the input rate of the brine is 4 gallons per minute from this statement right here, 4 gallons per minute. And then we know that the output rate of the well mixed brine is 8 gallons per minute, and that one was from here. And then the starting amount is 400 gallons. Right? You're losing more as you're pumping out more than you're pumping in. So here we go. Let's take a look at what we have going on. So we know that dA dt is equal to Rn minus R out. So let's find those. Rn is going to be what's going in there. So 3 pounds per gallon times, so that's the amount of salt that's being pumped in, but it's being pumped in at a rate of 4 gallons per minute. So the gallons divide out, and we're left with 12 pounds per minute. And then R out is a little trickier, right? So basically, you're going to have, we have to figure out at some time t what's happening. So for R out, we have to think about this. We know we have some amount at time t, call it A, but we have to figure out what is left. So you start with 400, right? Minus you're pumping out faster than you're pumping in. So 8 minus 4, right? And then that's in pounds per gallon. And we got to multiply that times the 8 gallons per minute. So this part right here is representing the net amount that's leaving. Okay, so simplifying for R out, let's see what happens. We'll get 8A, the gallons divide out, right? 400 minus quantity 8 minus 4, and sorry, that's times T, is going to be 400 minus 4T, and this is all in pounds per minute, which is good. And then simplifying, we'll get R out is taking a 4 out of each term, we'll get 2A over 100 minus T. Okay, so let's put that over here. So we've got this as kind of our notes. So dA dt will be equal to Rn, which is 12. I'm going to take the units off because the units are all the same, pounds per minute. And then minus 2 over 100 minus T, I'm separating it, and then times A. Now, to get this in the form where we can use where it's a linear DE, we'll get dA dt and the other a term on one side and the constant on the other. So we will have dA dt plus 2 over quantity 100 minus t times a equals 12. Good so far? All right, so now for the integration, right? So here we go. P at t is the coefficient to the a term. So we're going to have 2 over 100 minus t. And so e to the integral p at t dt equals e, I'm going to factor out the 2 to the integral of dt over 100 minus t. Well, 100 minus t, we've got that negative in front of the t, so we want to balance that out. So we need a negative dt to integrate, and then that's going to give us e to the negative 2, whoops, sorry, be consistent with the color. That's going to be e to the negative 2 natural log absolute 100 minus t. But remembering that power rule, I can bring it in. And then I'd have the natural log of 1 over 100 minus t, the quantity squared. So I don't need to put absolute value anymore. That's, in a natural log. I don't need to put absolute value anymore because 100 minus t, that quantity is always positive. All right, so when I square it. So now I'll just have 1 over 100 minus t, the quantity squared. So that's my integrating factor. So when I multiply both sides by my integrating factor, then what'll happen is, we remember engineered this like this, we're going to get d dt of your integrating factor times a. So 1 over 100 minus t, that quantity in the denominator squared, times a. So if you were to differentiate this with respect to t, you would end up getting this product. If you were to multiply that through, you would get that same thing, and that's what we set up. And that's going to be 12 over 100 minus t, the quantity squared. Continuing, we will have 1 over 100 minus t squared dA is equal to 12 dt over 100 minus t, the quantity squared. And sorry, there's parentheses around this one too. I misspoke. So I have to integrate both sides. So the left side I'm integrating with respect to a. So I'm just going to get 1 over quantity 100 minus t squared times a on the left side. Now the right side, you've got a quantity 100 minus t raised to the negative 2, right? So you're going to have 12 times quantity 100 minus t raised to the negative 2 dt that needs to be integrated. And so I need a negative dt, right? So I got to adjust again by a negative on the outside and a negative on the inside, which I'll put with that dt in order to be able to integrate. So we will get 1 over quantity 100 minus t squared times a is equal to negative 12 times quantity 100 minus t raised to the negative 1 using the power rule over negative 1 plus my constant of integration. So continuing to simplify, we'll have 1 over 100 minus t quantity squared times a equals, the 12 now will be positive, and we'll have it over 100 minus t plus c. All right, so now we want to clear out the 100 minus t quantity squared from the left side. So we'll multiply both sides, including the constant, by 100 minus t, the quantity squared. And then when we do that, we'll get a on the left side as per our evil plan. And then 12 times quantity 100 minus t plus c times quantity 100 minus t squared. Cool so far? And of course, we can just write that as a at t equals. Now that we're done working through all this, and let me simplify this part a little. We'll have 1200 minus 12t plus c times quantity 100 minus t squared. Now at time 0, right, there's no salt in there. So applying our initial condition, right, so a at 0 is 0. And so we'll get 0 equals 1200 minus 12 times 0 plus c times 100 minus 0, the quantity squared. That's going to give us 1200 minus 0 plus c times 10,000. So, continuing to solve for c, we'll have negative 1200 equals to 10,000 c. Negative 1200 over 10,000 is equal to c. Taking out a 4 from both, or a 400 really, we'll end up getting negative 3/25 is equal to our c. And so, drum roll, a at t is equal to 1200 minus 12t minus 3/25 times 100 minus t, the quantity squared. And if you write it in, descending powers, probably looks prettier to write it as a at t equals negative 3/25 times quantity 100 minus t squared minus 12t plus 1200. Good? And that, let's see, I think we answered everything. They might have also asked about how long in minutes will it take for the tank to be empty after this process starts. So this is going to be, just so you know, is in pounds of salt. Okay, and then do you see that here, the most that if you go all the way back here, 100, R out is 100 minus t, and 2a over 100 minus t. And so the tank's got to empty out in 100 minutes, right? Will it that's how long it's got to take for the tank to empty out. So the tank empties in 100 minutes. All right, so I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And if you like what I'm doing, go ahead and hit that subscribe button and like the video. Bye.